Anyways, this was a sort of conventional thing. You proliferate, you get almost necessity if nothing happens, hypoxia. Hypoxia leads to HIF being turned on. HIF turns on the MET receptor, which then promotes the mesenchymal formation. And then it can go backward. And here's the MET receptor. Not very well studied, but studied well enough so that I think there are 25 different companies trying to make inhibitors of MET. So it's not as if people don't realize it. And so the thought would be that if you could turn off MET, maybe then you could have Avastin, and you would stop the tumor growing while it's still epithelial. And you wouldn't have to worry about the mesenchymal thing. This is now being tried in San Francisco by Donald McDonald, who's used several MET inhibitors, and since it's in mice, Avastin does, you get an immunological response, so he has a monoclonal against the VEG receptor. And he says he was sending off a manuscript about a week ago. I saw him about 10 days ago. And I said, please send me the manuscript. You know, we'll see if it gets published quickly or whether it's the typical fate of being held up by failed postdocs who become the editors of the major journals. Yeah, it used to be decisions were made by, you know, serious scientists who were editors. Now they're made by people who can't get an academic job. No, it's bad. No, the horrors of it are many things. Anyways, this is a very important receptor because blocking it may be a way of keeping the cells epithelial, and we can probably fight epithelial cancers. But sarcomas aren't epithelial, and that's why sarcomas are so terrible. The way we try and fight just won't work. Now I'll go back, and I got very interested in my sort of when did I become anti-Folkman? Well, it was when I was told I have grade 6 Gleason, famous Gleason, who, you know, Gleason 6, 7 will tell you whether your prostate cancer is dangerous. So I have a so-called low-grade one, but it did make me get interested in should I be taking something to keep my grade 6 grade 6. Okay, and a paper just came out which really caught my fancy by Greg Semenza of Johns Hopkins, who works on HIF. And he pointed out that people who take, have heart failure and take glycoside drugs. I can't, my brain doesn't work like that. But anyways, glycoside, you take them, millions of people are on them, they get less prostate cancer. So many drugs, you know, whether you knew it or not, are anti-HIF. And it turns out, yeah, there's a list of drugs that work by inhibiting HIF. And to me, you know, the topoisomerases were particularly all the microtubule things. Taxol, Taxotere. So what it's doing is essentially keeping you from going mesenchymal. At least that's my interpretation of it. And he went through and then tried to go through all existing drugs to see if he could find a better one. And acroflavin, Paul Ehrlich found the first one. It's enormously effective anti-F. But it also binds to DNA, and in bacteria causes insertions and deletions, so it's possibly mutagenic. But if I had really bad cancer, I would just take acroflavin. Because it was widely used as an antimicrobial agent before, the sulfonamides, etc. And they claim, though, that other things. So a lot of the literature, you can say, isn't that good? But I think it is. And but then you can see HIF turns on glycolysis, and then HIF blocks the mitochondria from, leads to the Warburg effect. So HIF is the chief thing which makes, the cells secrete lactate. Now, then the other thing, if you then try and go through the problems, the major problem of, if you're studying look at advanced cancer, is that they become resistant to apoptosis. That is, your chemotherapeutic agent will, or DNA damaging agent, the cells aren't killed. Okay. And so you've got to find a way, basically, to kill cells which isn't apoptosis. Okay. Yeah, but p53 is the sort of major guardian of apoptosis. And p53 comes on and, leads to apoptosis and promotes DNA repair, stops the cell cycle. Essentially, it, prevents cancer cells from dividing. If you lose p53, bad news. In fact, most advanced cancers, by the time they're killing people, are p53 minus. And therefore, you lost apoptosis. And then you can say, this is sort of all the, so the enormous amount of work on trying to get new drugs which will cause apoptosis by playing with the known pathways. And I've heard talks which make me think some of them may be good, but they haven't reached the clinic. And then I'll go back here to the second control factor, AMP kinase, which, if you don't have it, there are sort of cancers can be caused by tumor suppressors are losses of activators of AMP kinase. And it turns on p53. So you want to turn on AMP kinase and you want to turn off HIF.